All right, so if you're studying library and information science, I want you to lean in because we're about to tackle one of the most fundamental concepts in your entire field. We're talking about indexing, that invisible engine that honestly powers how we find just about anything, anywhere.
I mean, just stop and think about it for a second. We are absolutely swimming in information. It's in books, it's in databases, it's all across the web. So how in the world do you find that one specific thing you're looking for without just getting completely lost at sea? This isn't just a new problem, you know? It's a core challenge of managing knowledge. And the answer? Well, it's indexing.
And you know exactly what I'm talking about. We've all done this. You're knee-deep in some huge textbook, and you need to find every single mention of a specific person or idea. You don't read the whole thing again, right? No way. You flip to the back, scan that alphabetized list, and boom, there are the page numbers. That right there, that's indexing in its simplest, purest form. It's a roadmap.
Okay, so let's break that down. At its very core, indexing is really about just two things, a list and a pointer. The list has all the important stuff, the keywords, the names, the big ideas, and the pointer, well, that could be a page number, a website URL, or a library call number. It just tells you exactly where to go. That's it. It's a simple but powerful system for organizing information so you can actually find it again.
I love this quote because it just hits the nail on the head. An index isn't just some boring list, it's a bridge. Think about it. It connects a person's question on one side with the answer that's hidden in this massive mountain of data on the other. Without that bridge, all that information might as well be on another planet. It's basically lost.
So we get what it is, but let's dig into the why. Why is this so incredibly important? What are we really trying to do when we sit down and create an index?
When you boil it all down, it's really about two things, speed and access. We index to bring order to chaos, plain and simple. It makes sure that people can find what they need and find it fast. And in the end, that saves a massive amount of time, energy, and resources for everyone.
And if you want to see the sheer power of indexing on a mind-blowing scale, look no further than Google. Seriously, just try to imagine searching the internet without an index. Every single time you typed something in, a computer would have to scan the entire web in real time. It's impossible. Indexing is what allows search engines to build this gigantic, pre-organized map of the web, and it's why you get your results in like half a second.
Now, the back of the book index is a fantastic starting point, but the concept of indexing is so much bigger than that. It really takes on all these different shapes and forms depending on where you're using it. Let's just look at a few. For a book, it's about navigating one single document. For a search engine, it's about sifting through billions of web pages. In a big company database, it's all about making queries run faster. And for scientists, it's about making sure crucial research doesn't get buried. See the pattern? The context changes, but the goal is always the same. Connect the user to the right info fast. Okay, so let's bring it all back home, back to the library. Because for anyone studying LIS, this is your world. This is where the rubber meets the road. How does all this indexing magic happen inside the library?
You know, it really wasn't that long ago that a library's index was a physical thing, a giant cabinet full of little cards. You had to physically walk over and flip through drawers to find a book. Today, that entire cabinet is a search bar on a screen. We call it an OPAC. The underlying principle is exactly the same, but the technology has totally transformed the experience.
And of course, the way books are organized on the shelves is a type of physical indexing too. You're going to live and breathe these two systems. You've got Dewey Decimal, or DDC, which uses numbers to group books by big subjects, you know, the 500s for science. Then there's the Library of Congress, or LCC, which uses letters and numbers for way more detail. That's why you see it in huge academic libraries.
So how does a new book get into the system? Well, it's basically a three-step dance. First, the book gets classified. It gets its DDC or LCC number. Next, it's cataloged, which means creating that rich digital record for it. And finally, the magic step. That record gets indexed, which is what makes it pop up when someone searches for it in the catalog. That last step is what connects a user's thought, like climate change, to a physical book on a shelf.
And this whole thing runs on a concept that you absolutely have to know, metadata. It is the lifeblood of indexing. Simply put, metadata is data about data. For a book, it's the title, the author, the subjects, the publication date, all that good stuff. This is the information that actually gets indexed. The richer your metadata, the more ways a user can discover an item.
Okay, let's wrap this up. We've covered what indexing is, why we do it, and how it works pretty much everywhere, especially in the library. So, what's the big idea here? What's the one thing you really need to take away from all this?
It's this. Indexing is what turns a pile of books into a library. It's what turns a giant jumble of websites into a search engine. It is the invisible, essential structure that takes raw, chaotic data and transforms it into organized, accessible, and truly useful knowledge. And this all leaves us with a really fascinating question to think about. You know, as AI and machine learning get better and better at understanding language and context, what's the future role for the human expert, for the indexer? Will the art and science of indexing change? Or will that human touch become even more important than ever? That's something we'll all be figuring out together.